So section 3.3 is not the section where we need the special features on our TI-83 or 84 calculators. That's coming up in the next section, so I was just a little excited to get to that, but we will get to it on the next section. So this should be an easy section. This is a section on averages, which I call measures of central tendency. And there's 4 kind of averages that we're going to study in this section, and you might be familiar with all of them. You'll definitely be familiar with 1 or 2 of them. We're going to study mean, median, mode, and mid-range. And mean is probably the most common average, and it's just the sum of all the information or the data that's given divided by the number of data pieces. And the symbol for mean, and it's actually the symbol that our calculator uses, is an X with a bar over it. And what this means is to add up all the data. This little symbol here is a Greek letter sigma. It means add up all the individual data and then divide by the number of data. So this symbol right here is a symbol that I'm comfortable with. It's not a symbol that you really need to know. We just need to know how to calculate a mean given some data, and so that's what the first example is for. 5 people are waiting in line at a Jack-in-the-Box drive-through. Here are their ages: 27, 18, 48, 34, and 48. What's the mean age of this group? To find the mean, I add up the ages: 27, 18, 48, 34, and 48. And then because there's 5 numbers here, I'll divide by 5. So on my calculator, I did 27 plus 18 plus 48 plus 34 plus 48 divided by 5 and got 35. If I wanted to do that on my calculator and I wanted to do it in one computation, then I'm going to need a parenthesis. So I'm going to go parentheses 27 plus 18 plus 48 plus 34 plus 48, close my parentheses, and then divided by 5. And I can get the 35, which is the mean age of the people waiting in line at the Jack-in-the-Box here. So that's all the mean is just the sum of the data divided by the number of data pieces. Here, there were 5 data pieces. I added up the 5 numbers and divided by 5 and got the mean age of the people waiting in line at the Jack-in-the-Box drive-through. The median is the middle value if the data is ordered. So the ages for the people at the Jack-in-the-Box were 27, 18, 48, 34, and 48. That's how the data was given. I couldn't find the median age of the people waiting in line at the Jack-in-the-Box from how the data was presented, because the median is the middle value provided the data is ordered. So if I wanted to find the median age of the people waiting in line at the Jack-in-the-Box, I'd need to take the data or the ages and order it. And it wouldn't matter if I went from smallest to largest or largest to smallest, and because it just seems more natural to go from smallest to largest. When I did this, I went from smallest to largest, and now I'm going to find the median. So once we have the data ordered, or which we can call ranked, what I'm going to do is one at a time remove the last number and the first number. So I'm going to remove the first number from the list and the last number from the list, and then I'll have a shortened list. From that list, I'm going to remove the first number and the last number. If there's only one number left after you repeatedly remove the first and the last number, that number is the middle value, which we'll call the median. So for our Jack-in-the-Box ages, we ordered the ages, we struck out the first and the last number, then the second from the first and second from the last. We're left with one number in the middle. Median kind of means middle, and the median or middle value is 34, the median age of the people waiting in line at the Jack-in-the-Box, which was different than the mean age. The mean age was 35. Now, median can be a little bit tricky because sometimes when you go through the scratching out process, you'd either have to scratch out all the data or you'd be left with 2 numbers in the middle, and here's an example that tells us what to do for that. So here's some ordered data that I want to find the median for. And so to find the median, once my data is ordered, I cancel out the first and the last number, and then the second number and the second from the last number, the third number and the third from the last number. If I repeated that process, I would have crossed out all the numbers. That's not good. So there's not just one number that's the median. I have to, when there's two numbers in the middle, I have to add them and divide by 2. So for this data, it was in order, so I can go and try to find my median. But when there's two numbers in the middle, or when the striking out process would cancel out all the numbers, I have to take the two numbers that are in the middle and add them. And for this data, the median number, or just the median, is going to be 6. So the median it can be tricky. The median can be one of the numbers in the data point. That's if there's an odd number of data points. In the Jack-in-the-Box example, there were 5 data points, and when there's an odd number of data points, 5 is an odd number, the median is one of the actual data points. In this next example, there are 1, 2, 3, 4, 5, 6, 7, 8 data points. When there's an even number of data points, the median won't necessarily be one of the data points. There'll be two numbers in the middle when you go through the crossing out, and you have to average those two numbers. The mode is the piece of data that occurs most often. And in this Jack-in-the-Box, these are the ages of the people waiting in line at the Jack-in-the-Box. And the mode is the most frequently occurring number. And in this case, 48 is the most frequently occurring number. So we'll say that 48 was the mode. The next example gives us a set of data where there's more than one mode. So in this case, 48 was the only number that occurred more than once. It occurred more than any other number, so it was the mode. In this next set of data, when I look at it, let me see, there are 2 2s, 3 3s, 1 5, 3 7s, 1 9, and 1 12. Well, the mode is the number that occurs the most. 2 doesn't occur the most because it only occurs 2 times. 5, 9, and 12 only occur 1 time. But 3 and 7 both equally occur 3 times. So I'm going to call those both a mode. And I'll say this has 2 modes. This is considered bimodal data. At the extreme, we can go to trimodal data. We could have 3 modes. But once we start getting more than 3 modes, I'm just going to say there's no mode. And in a data set like this, the only 5 numbers are 1, 3, 5, 7, and 9. Each only occurs once. It wouldn't be wrong to say this has 5 modes. 1, 3, 5, 7, and 9 are the modes. And I don't know what that would mean. Pentamodal maybe. But I'll just say it has no mode. So if there's a single number that occurs most, that's the mode. If there's 2 numbers that occurs equally most, it's bimodal. If there's 3 numbers that occur equally most, it's trimodal. And then beyond that, we'll say it doesn't have a mode. So here, instead of saying there's 5 modes, we'd say there's no mode. The last of the averages that we need to learn is mid-range. And mid-range is just the lowest plus the highest number divided by 2. So in the Jack-in-the-Box problem, if I was asked to find the mid-range age of people waiting in line, I'd find the lowest age, which was 18, and the highest age, which was 48, and it doesn't matter which of the 48s I'd pick. I'd take the lowest age plus the highest age divided by 2, and on my calculator, if I wanted to do that, I'd go parentheses 18, which is the lowest age, plus 48, which is the highest age, close the parentheses, divide by 2, and I'll get the mid-range age is 33. Mid-range isn't something that I really ever use. I'm required to teach it, so I'm teaching it. But mean, median, and mode you hear frequently. Mid-range, it's really infrequently ever mentioned in statistics classes. All right, so there's one more kind of problem that we're going to get in this section, and then I'm just going to do all the problems. And so, well, and I kind of stretch these into 2 problems, so that I maybe I should say there's two more kinds of problems. And the first kind of, this problem is just a link to a more complicated problem. So Cindy's mean average score on 7 tests was 80. Find the sum of her scores. And to do that, you just take the number of tests times the average on each test, and that will tell you the sum of her test scores. So Cindy's test scores will be 560. The 7 tests times the average of 80, and that's assuming each test is worth 100 points. If each test was worth 50 points, then you'd have to probably take half of that. If each test was worth 200 points, you'd have to double that. So for this class, for this section, unless it's otherwise specified, every test is going to be worth 100 points. And so to find the sum of somebody's tests, if you want to add, if you don't know the individual test scores so you could add them up, you just multiply the number of tests times the average on each test. This is the kind of problem that is what I thought was going to be the last kind of problem. So for this particular class, you need to average 90 on 5 tests to get a final grade of an A. Thurston from Gilligan's Island, not that any of you know what that is, has taken 4 tests, and these are his scores. So Thurston's looks like he's getting an A because that's an A, a B, an A, and an A. The question will be, what does Thurston need on his last tests to lock up that A? What's the least he could score on his last test to get an A? So there's 2 things that I need. I need to know how many points are needed for an A, and the number of points needed for an A, you need to have an average of 90 on 5 exams, and that to average 90 on 5 exams, you need 450 points. So I take the average needed times the number of tests I need to get that average on. That will tell me the total points needed for that grade. In this case, I need to average 90 on 5 tests. I need 450 total points needed for an A. Now I add up Thurston's scores that he has so far, which are, 93, 85, 95, and 90. And that must be 363. Let me check that out here. Make sure I haven't fudged that completely. So 93 plus 85 plus 95 plus 90. Yeah, Thurston has 363 points so far, and he needs 450. The difference between the total number of points Thurston already has and the total needed for an A, that's the total he's going to need to score on the last test. So 450 minus 363 will give me 87. So Thurston, on his last test, if he gets 87 or greater, then he's going to keep his A. If he gets under 87, then his average will be less than 90, and he won't technically get an A, be deserving of an A. Next question is, what would Thurston need to get a B? Well, so what an average of 80 on 5 tests is needed to get a B. So first I'm going to compute how many points are needed to get a B. The total points needed is the average required times the number of tests that you need that average on. The average required is 80. It is on 5 tests. 80 times 5 is 400. So you would need 400 points in this class to get a B. Thurston, his scores were 93, 85, 95, and 90, so they added up to 363. The difference between the number of points needed for a grade and the total points you already have would be the number of points you need to get that grade. So 400 points are needed for a B. Thurston has 363 points. The difference between 400 and 363 are the 37 points that Thurston will need to get a B in this class. So he needs 87 for an A, 37 for a B. This is a little bit trickier, part C. This kind of is how this class works, because if you take the final exam, I drop your lowest test. So it's a good it's relevant to us. So for Thurston, let's assume he's in a class where they drop your lowest test. So Thurston's test scores were 93, 85, 95, and 90. So for Thurston, we're going to drop that 85, and we're only going to count the 93, the 95, and the 90. So if we throw out the 85, then Thurston has 278 points. Question is, how many points will he need to get an A, and how many points does he need on the final? Well, in this problem, there are 3 tests that we're counting, plus the next test, which is I guess the final exam. So we're going to count the 4 best scores, the 3 regular test scores that are best, and the final exam. So there's going to be 4 tests that we're going to be added or counted for Thurston's final grade. He needs to average 90 on those 4 tests. So the 90 that he needs to average times the 4 tests that are going to count for the final grade, the 3 that aren't your low test plus the final exam, that means you need 360 points total to get an A in this particular class, because we're dropping one of the 5 tests. So the difference between the 360 points that you're going to need when you're only counting 4 tests and the 278 points that Thurston has, that's going to give me the 82 points that Thurston needs. So you see me crossing out a bunch of numbers, because somewheres on the first, when I started doing this, I had a 92 for one of the test scores, and I don't know why that came out that way, but I fixed it along the way, so hopefully that was easy to follow. If not, we'll do a handful of word problems like this, and you'll be able to follow right along, and it won't be, this being a 92 and I changing it to a 93 is throwing you. It won't throw you when we get a little bit further into this. All right, so first 8 problems, 1 for me, 1 for you. I'll do number 2, and you can do number 1, and then check your answer. To do the mean for number 2, I'm going to add up the scores: 1, 2, 1 plus 2 plus 3 plus 5 plus 6 plus 6 plus 7, and I have to divide by 1, 2, 3, 4, 5, 6, 7. I have to divide by 7 because there's 7 pieces of data, and I'm just going to use my calculator because it can do it just fine. So on my calculator, I go parentheses 1 plus 2 plus 3 plus 5 plus 6 plus 6 plus 7, close out my parentheses, divide it by 7, and it doesn't say where to round. So I'm going to round to 2 decimals because I'm kind of consistent that way. So I'm going to say the mean is 4.29 because the 5 in the 3rd decimal place will cause me to round up. Let me make sure I did that right. So this is 3, 6, 11, 17, 23, 30 divided by 7. That's exactly that. So the mean I'm going to say is 4.29. Now I'm going to do the median, which is the number in the middle. So I'm going to take the data. It's nicely ranked or ordered for me, which is good. And I'm going to cross out the first and the last, the second and the second from the last, the third and the third from the last, and the number that's left, if there's a single number, that is the median. The mode is the number that occurs the most, and in this case the mode is the 6 because the 6 is the only one that occurs more than once. It occurs more than any other number. And the mid-range is the low number plus the high number divided by 2. The low number in data set is 1, the high number is 7. This is 8 over 2, so the mid-range is 4. So hopefully that was easy to, hopefully you didn't even have to watch it and you were able to do number 1 and you can just fast forward through this. So let me work on number 4 while you work on number 3. For the median, for the mean, it doesn't matter if the data is ordered or not. So for my mean, I'm going to go 21 plus 25 plus 29 plus 27 plus 15 plus 21 plus 28 plus 13, and I divide by 1, 2, 3, 4, 5, 6, 7, 8. And again, there's no reason to do that without a calculator. If I'm doing this with a calculator, I have to have a parentheses for the numerator. So parentheses 21 plus 25 plus 29 plus 27 plus 15 plus 21 plus 28 plus 13. Close my parentheses, divided by 8. And I'm going to round to 2 decimals again just to be consistent with how I normally do things. So I'm going to write 22.38 because that 5 in the 3rd decimal position will cause me to round that up. If you gave me 22.375 and didn't round it, if I don't have instructions as to where to round, then you don't have to round. But it's just, I don't think there's been a problem this semester that I've carried more than 2 decimals. For the median, I need to rank the data. So 13 is going to be first. 15 is going to be second. 21 is going to be third and fourth. And then 25, 27, 28, and 29. So that's the data written in order. 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. Finding the median destroys the data, how I do it. The mode is going to be easy for this one. The mode is the one that occurs most, which is 21. So I'm going to pop out the mode in the mid-range before I destroy the data to find my median, because I can see 21 is the most frequently, the number that occurs most, and the mid-range is the lowest number, 13, plus the highest number, 29, divided by 2. Parentheses that out, so 13 plus 29, close out my parentheses, divided by 2, and I get 21 for the mid-range. Oh wow. And now for the median. Cross out the first and the last. Second, second from the last. Third, third from the last. I'm left with 2 numbers, so I need to add them up and divide by 2. So the median for this is going to be 21 plus 25 over 2. It's going to come out to 23. I'll do it on my calculator just to show you. And on my calculator, it'd have to be in a parentheses. I'd have to go parentheses 21 plus 25 parentheses divided by 2, and you'll get the 23. Alright, so 2 more of these mean, median, mode, mid-range problems, and then a few word problems. Okay, so I'll do 6, you can do 5. When you do 5, I'm going to say it's bimodal. So for number 6, first one I want to find is the mean. The mean, I'm going to go 2 plus 2 plus 4 plus 5 plus 5 plus 6 over 6, because there's 6 pieces of data. So 2, better do parentheses, so parentheses 2 plus 2 plus 4 plus 5 plus 5 plus 6, close my parentheses, divided by 6, and I get a mean of 4. Because the data is ranked, I'll just jump right into my median, and I could use the data up there to find my mode and mid-range. So for the median, list the number in order, cross out the first and the last, the second and the second from the last. Now there's 2 numbers. If I crossed them out, I wouldn't have any numbers left, so I have to average those 2 numbers. I'm going to go 4 plus 5 over 2, and I'm going to get 4.5 for my median. You can do that on your calculator, but I can definitely do that in my head. For this set of data in problem 6, the mode is the one that occurs the most. Oh, it's bimodal. It's both 2 and 5. So I'm going to say it's bimodal. I'm just going to say the mode is 2 and 5. I'm not even going to write the word bimodal in there, but it would be fine to do that. And yours should be bimodal as well. My mid-range is my smallest number 2 plus my largest number 6 divided by 2. That's 8 over 2, and the mid-range is 4. So mean 4, median 4.5, bimodal, the mode is 2 and 5, and mid-range is 4. One more problem, and then the word problems. Okay, so I need to do the mean first for number 8, and you can do number 7. So I'm going to go 6 plus 7 plus 8 plus 9 plus 5 plus 4 plus 3. That's 3, 4, 5, 6, 7. I'm going to divide by 7. Calculator, parentheses, 6 plus 7 plus 8 plus 9 plus 5 plus 4 plus 3. Close out my parentheses, divided by 7, and I get a mean of 6. I have to order the data to do the median, and it's going to be easy to order. I'm just going to go 3, 4, 5, 6, 7, 8, 9. So the data ordered is 3, 4, 5, which are those three numbers written in a nice order, then 6, 7, 8, 9. And because I'm going to destroy the data and the original data is not ordered, I'm going to do the mode and the mid-range before I find my mean. I'm going to say there's no mode rather than saying there's 7 modes, so I wrote none for mode. And then the mid-range is the smallest 3 plus the largest 9 over 2. That's 12 over 2, which is 6. So mean 6, no mode, mid-range 6. Now I'll find the median, cross out the first and the last, second from last, third from last. If you're left with one number, that is the number that we need here. So in problem 8, the median is 6. So mean, median, and mid-range are 6, and there's no mode. Now the word problems. So the simple word problem, this is supposed to be Brady Bunch. I clearly got pretty bored last semester when I was writing these problems, and my mind started just being stupid, I guess. So anyways, to find out the sum of somebody's scores, if you know their average and the number of tests, you just multiply. So for number 10, to find the sum of Peter's score, I'll take the 6 tests that he scored 74 on, multiply those together, and 6 times 74 is 444. So my answer to number 10 is Peter, the sum of his scores is 444. Yes. Same thing for 11 and 12. For 11, Bobby took 3 tests. He averaged 92 on those tests. If I multiply the number of tests times the average on each test, that will give me the sum of the tests, assuming each test is worth 100 points. So for number 12, the answer would be 276. So if you're ancient, this is a Sanford and Son reference. It's the same kind of problem. The last grade, how many points did you get, or what? And tests are just like how many points you'd get in basketball games. So for 13, Lamont played 20 games. He averaged 18.5 points per game. How many total points? You take the number times the average. That will give you the total. For my Grady problem, Grady's car gets 25 miles per gallon. He used 10 gallons of gas. So if I take the 25 miles per gallon times the 10 gallons that Grady used, that tells me he went 250 miles. Oh, all right. So 15 and 16 are just more of the same one-step problems. If a sub shop sells 70 sandwiches per day on 7 days, how many sandwiches do they sell? You should be able to hopefully figure that out. A new car salesman sells 5 cars each week. How many cars does he sell in a year? Assume that he takes 2 weeks of vacation. There's 52 weeks in a year. This guy's only working 50 of the weeks. So the 5 cars that he sells for every week that he works times the 50 weeks that he works each year is going to let him sell 250 cars in a year. Now the multi-part problems. So you might be able to just jump into the part A, B, and C of number 17. It's like an example that I've already done. If not, you can watch me do 18, and then after I do 18, you can rewind and do 17. So if you're ready to do these problems, do them. If not, come back after you watch me do number 18. So 18, Beverly Hillbillies. So Ellie needs to average 70 on 6 tests to pass. So I'm going to do 2 computations. I'm going to find the number of points that are needed to pass. And that's 6 exams at 70 average. That would give me 420 points needed to pass. And from that, I want to subtract how many points Ellie already has. And Ellie already has, let me just do this, 55 plus 77 plus 72 plus 64 plus 95. So Ellie already has 363 points. The difference between the points that she has and the points that she needs is going to be what she needs to get on her last test. So I would go 420, which is the total points needed to pass, minus 363, which is the total points that she has, and the answer to part A of number 18 is she's going to need 57 points on her last test or on her 6th test to get a passing grade. I'll have to carry this 363 forward, I imagine, quite a bit. So part B says an average of 80 is needed to get a B in the course. Is it possible for, it should say Ellie, to get a B? And if so, what must she get? Well, to get a B, so I need number of points needed. She needs 6 tests at an average of 80, so she needs 480 points. And I'm going to minus her total points so far, which is 363. And the difference between 480 and 363, so 480 minus 363 is 117. That's what she would need to get a B. So I'm going to say it's not possible for Ellie to get a B because she can't, if the test is only worth 100 points, she can't get 117. So it's not possible to get a B. And probably the last part, if the lowest grade is going to be dropped, what does she need to pass? So in general, you need 6 tests at 70 points each, but now we're dropping your lowest tests. So to pass the class, you're only going to need 5 tests at 70 points each, which are 350 points now to pass. And we're dropping this test, so I'm going to drop the lowest test. So for the points that she has so far, I'm just going to add up those 4 test scores, 77 plus 72 plus 64 plus 95, because those are the ones that we're keeping. So 77 plus 72 plus 64 plus 95. So when we drop her lowest test, she used to have 363 points. That's counting all 5 tests, or all 5 tests she had already taken. If I only count the 77, the 72, the 64, and the 95, and if I add those test scores up, you'll get that she has 308 points. The difference between the 350 that you need to pass when you're dropping a test minus the 308 points that she has when we drop her lowest test tells me that she would need 42 points to pass this class if the lowest test is being dropped. That's different than the 57, so it makes it easier for her to pass. So part C is 42 to pass. And I could say if we dropped her lowest test score, but I won't add that in there. All right, so 19 has a part A and a part B, and you might be able to go through it and just pause the video and go through it, or you might need to see me do number 20. I think it's a lot the same, so hopefully you're going to be okay with this. If not, watch me do number 20. So number 20, a mean average of 70 is needed to pass the course. Oh, a little twist to this. The first tests were worth 100 points each, and the final exam was worth 200 points. This is a good twist because this is going to mess you up. So here's how the tests go. First test is worth 100 points. Second test worth 100 points. Third test worth 100 points. Fourth, 100 points. Fifth, 100 points. And then the last test, the sixth, is going to be worth 200 points. So in this class, there's going to be 700 points possible at the end of the semester. So if I want to find out the points needed to pass, well, I need to average 70 out of 700 points. So what I'm going to do is I'm going to write a 70 as a decimal, a 70% as a decimal, and multiply it by the total number of points that are going to be available at the end of the semester. So if I take 70%, which is an average of 70, or 0.7, and then times 700, that would tell me that Ellie is going to need 490 points to pass. Well, we already know what she has. So she has 55 plus 77 plus 72 plus 64 plus 95. She has 363 points. The difference between the total number of points you need at the end of the semester and what you have is what you need on the last test. So I'm going to take 490 and subtract 363 and get 127. So she needs 127 out of 200 points on the last test to pass. A little bit harder with the 200-point test. So, can Ellie get a B now? Last time she couldn't get a B when the final was only worth 100 points. But how about now when the final is worth 200 points? Well, I'm going to do the same thing. Now, how many points does she need for a B? There's going to be 700 points possible, and she needs an 80%. So I'm going to go 0.8 times 700. So points needed for a B, you need 80%, which is 0.8 as a decimal. And in this class, there are now 700 points possible, 5 100-point tests and 1 200-point test, which gives me 700 points. And that means Ellie now needs 560 points to get a B. Well, she still has 363 points. So if I take the difference between the number of points that you need at the end of the semester and the points that you already have, so 560 minus 363, I get 197. It may not be likely, but it's now possible. In the last example with Ellie, it was impossible for her to get it a B. She needed 117 out of 100. But now that this last test is worth 200 points, she can actually do it. So she needs 197 out of 200 for a B. Oh, that's the last problem. How lovely. I was expecting more. So just in case you hadn't got to this, 19 you probably weren't ready to do because of that 200-point little twist in there. So you can take a stab at that and then check your answers. And then the next 3 sections are the sections that we're going to need the calculator's special features.